Alright, today we'll be talking about just the straight up bisectors. Now we talked about their properties last time. You can create some really cool triangles with the perpendicular bisector last time, but we're going to be talking about a lot of ways that you can actually work with this, okay? Alright, so let's say you have your triangle and you want to draw not on just one side, but you want to draw on all three sides the perpendicular bisector for each side. And so what you would do is you would just draw your perpendicular bisector, and obviously they would make 90-degree angles with the sides. You know, mine's a little bit off, just so you know. Alright. The cool thing is that they pretty much always intersect at a certain type of point. Okay, and we'll talk about this point in a sec. Let me get my markings all down. Okay, so these are the perpendicular bisectors, and they all intersect at a certain point, and that certain point is called the circumcenter. Okay, so the circumcenter is the center of a triangle. Well, not the center, it's the point at which it's the point where all the perpendicular bisectors intersect. Now, they could intersect in a lot of different places. Like, for example, if I was drawing an obtuse triangle, an acute triangle, which we just saw, so I'm not going to reproduce that. So let me get rid of this bad boy. Okay. An acute triangle, they intersect inside, and then we're also going to look at what happens when they intersect right here. Okay, on a right triangle. Okay, so in an obtuse triangle, okay, our perpendicular bisector will go out this way, okay, but also right here it intersects and it goes out this way. Pretend I drew this correctly. Okay, so in a perpendicular bisector that is obtuse, the points, the circumcenter will actually be outside of the triangle. Okay, now inside of a triangle, or inside of a right triangle, okay, our perpendicular bisectors will go like this. And amazingly enough, I know mine's off a little bit, but the circumcenter will be on the actual triangle. Okay, so this is outside. This is on the triangle. And this is inside the triangle. Okay, alright, so just taking a look at those, you now know what's going to happen with the circumcenter of a triangle and circumcenter about the triangle, okay? Alright, now here's the other cool thing. Okay, if I were to reproduce a drawing of a circle, okay, and draw it around these points, okay? So let's say I drew the circle around these points. Now here's the cool thing. As I draw my circle, okay, mine's a little bit off there. Pardon that horrible drawing. Let's draw again. Not only will the edges be on the vertices be on the actual circle, but the circumcenter is actually the center of a circle drawn around the triangle. So that's actually a really cool thing to know too. So if I actually had to combine the shape of a triangle and the shape of a circle, and then put the edges of the triangle on the circle, I would know that the circumcenter of that triangle is actually the center of the circle. So if I can mix and match them. So that's honestly an amazing thing with a circumcenter. It's really cool. Alright, now what if we take a look at the other bisector, which was the angle bisectors? Okay, all right. Now they pretty much only occur in, well, I mean, they're going to occur inside the triangle anyways, because you're only dealing with the angles inside. So we're not going to look at any other situation than an acute. Okay, but an angle bisector, we want it to go to the other side. It's going to cut the angle in half, and voila. You have another point of concurrency. Point of concurrencies are these things I'm talking about. The point of concurrency for the perpendicular bisectors is called the circumcenter, and for the angle bisector, it's called the incenter. And amazingly enough, it does have to do with the circle again, but instead of being outside of the circle, being outside of the triangle, the circle's on the inside. All right? And it's really cool how this works, okay? All right. Now, the really cool thing is that a lot of people forget about, well, no, not, let's get it different, there we go. Okay. A lot of people forget about this stuff, is that the actual sides right here, these sides right here are all going to be congruent, and so are these sides. Okay, some really cool properties. Let me take that back. The only ones that are actually congruent are the ones inside of the inside circle. Okay, that was my bad. I spoke a little bit ahead because it's messed up. But these other measurements, these are exact, you know. Okay, so those measurements are actually equal, and the incenter is going to be right there. And the incenter is actually the center of the circle inside of the triangle. Center of circle inside triangle. Okay, so it's really cool. And yes, these are the radiuses of this small circle. So radius, radius, and radius. Okay. All right, and this one out here, you can't really say anything about the measurements of the actual perpendicular bisectors themselves. You can just say what they do to the triangle, okay? And that's pretty much it for our bisectors and triangles. Thank you. Have a great day.